Polyatomic molecules and polyatomic ions. So far, all of the compounds, either ionic or covalent, that we have looked at have been made from only two elements at a time. We have seen that many ionic compounds have more than two atoms, even if they only have two elements. For example, sodium oxide has two sodiums for every oxygen. But the covalent compounds we have seen so far have only two atoms, O2, H2, N2. This is not always the case. Let's take a look at hydrogen and oxygen. Hydrogen can share its one electron with oxygen, but that leaves oxygen still needing one more electron. If we add another hydrogen, we can form water, H2O. Oxygen has a complete octet, and hydrogen has its single shell full with two electrons. Now let's look at nitrogen. Its electron dot structure shows that it needs 3 more electrons to have a complete octet. If we react nitrogen with hydrogen, we will get ammonia, NH3. This is sometimes used as a cleaning agent. Once again, we have a complete octet for nitrogen, or a full first shell for hydrogen. If we look at carbon, you can see we need 4 more electrons. So with hydrogen, carbon makes methane, CH4, also known as natural gas. This is a common fuel for heating and cooking. It is also being used more often now to generate electricity. This is what energy companies are after when they do fracking, which you may have heard about recently in the news. Because of its small size and space for bonding with 4 other atoms, carbon can make a large variety of compounds. This is the study of organic chemistry, and we will do more of this when we talk about the structure of the soap molecules. So let's take a look at hydrogen and oxygen again. After combining oxygen with one hydrogen, what happens if, instead of adding another hydrogen, we just add an electron? Maybe from something like sodium that wants to give one up. We now have an ion, a charged particle, but it is made of more than one atom. It is a polyatomic ion. Like monoatomic ions, polyatomic ions have different numbers of protons and electrons, and so carry a charge. That charge is not localized to a specific atom in the group. It is associated with the entire group. So these polyatomic ions have covalent bonds within the ion, but will then form ionic bonds with oppositely charged ions. For example, the compound we used to mix with the oils to make soap was sodium hydroxide, sodium ions, and hydroxide ions combined. Here are a few common polyatomic ions. There is a somewhat longer list on page 107 in your textbook. Note that negative polyatomic ions are more common than positive ones. The naming of polyatomic ions doesn't follow the same simple rules that monoatomic naming follows. The few positive ions usually end in onium, like ammonium. Many, but certainly not all, negative ions end in ate. So nitrate, carbonate. If you see the name of a compound with the ate suffix at the end, assume it has a negative polyatomic ion. In class, you will have a chance to practice making compounds using polyatomic ions.